Dear all, good evening. It is my pleasure to invite you for a lecture of Professor Emanuele Naboni, our visiting professor on behalf on Chair of Urbanism and Urban Structures Architecture, Faculty of Architecture, Cracow University of Technology. Professor Naboni is an international expert. He will show the list of all his affiliations, but he's our visiting professor from Canadian University in Dubai, but also from University of Parma and Royal Danish Academy of Architecture. So please, Professor, floor is yours.
Okay, thank you very much. First of all, big thank you to Professor Mateus and Professor Philip for the warm welcome. Each time I come here is special. And thanks for those that are using their time to see or to discuss some ideas. So we'll try to shift from page to page. As said, I have a few connection. I think this year I've had about 10 contracts with 10 universities, but also I operate as a consultant with my own firm, but more recently also with Atkins Realis. And I'm collaborating with World Health Organization and European Commission for matters of climate change. So projects are many and ongoing, and sleeping hours are little, and I will show some ideas. First, I would like to call attention to the fact, this is almost 20, that depending on the location, already in 2050, we're going to have several heat waves with our district strips, up to 20 degrees more when it gets really red and intense. Of course, we have also times where temperature get much lower. When we begin to look at climate change for different cities, climate change is very differential in the sense that certain location like Riyadh has about 6 degrees more flattened all over the year, whereas certain cities are characterized by frequent changes and frequent extreme. We are losing, in a way, the average condition that characterize these days. This has implication also on indoor comfort. It's a map of comfort hour within an office. These are the months of the year, and these are the times in the day. And this color are shifts into thermal condition within, for instance, an office. And we can see how actually the yellow is a shift from a temperate condition to a very warm condition. So as we can see, and this is just for summer, we have several changes also in our interior. These are differential. Each place is going to have extreme high changes, for instance in Riyadh, especially during nighttime, whereas in Rome, major changes happens in the central times of the day. So it's very important that we are able to understand how things are differentiating. And probably you have done some bioclimatic course when there is an angle that you use for gaining heat during winter. So this is a condition for Berkeley in California, where actually all the books will tell to use this red line for designing your building in order to harvest heat during winter. But this angle are shifting and getting reduced because winter are shorter and summer are longer. Winter starts later and ends earlier. As well as for summer, when we plan and design for shading system or overhangs for summer protection, we have to consider much lower angles because already in April we may have excessive sun radiation. So probably all of you have played with these charts, I believe, more or less, and with some success or some failure. I think I didn't yet fully understand this chart myself, But I understood that it's very useful to use angles to design facade or distance between building and urban design, and these are changing so much and so suddenly. So design is going to be modified, and the form of building, the distance between building is going to be modified. I'll show a first example, which is the city of Maranello, where Ferrari is, just to understand what can be the local effect of climate change. This is a collaboration with the office of Mario Cucinella, with which I collaborate. So we did models to understand within the center of the city what will be the real feel in terms of temperature in 2050. We can see that in certain part of the city, like this longer plaza, we have experienced temperature of about 45 degrees. And also this is affecting the energy consumption of buildings. And each building will have a higher temperature within the interior of a certain number of degrees. And we can see that certain buildings have almost no changes in their temperature, whereas others have. Let's just keep this in mind. When we go to the natural site, very interestingly, there are certain features that actually stay into stable temperature, like you would obviously think. And this is an industrial site. I wanted to pay attention to, are you aware of the topic of urban heat island? Have you heard of sitting warming up? Yes. Do you believe in urban heat island? Okay, I don't. And I will explain you why. So, historical center, and these are the surroundings. These are the changes into temperature. You can see lighter colors here, lower temperature. And here you can see higher temperature into the agricultural side and into the natural side, like with forest and rivers and so on. Higher temperature are experienced into the future, into the surrounding of the city, than into the center. This is a little bit of a new information for you, I guess. So this is why, this is due to the fact that when there is vegetation, actual vegetation is not capable to adapt to future temperature. So tree, according to this model, that where each tree actually is modeled according to is resistant to radiation and temperature. So what we have is that more agricultural crops and paths, as well as natural system, are actually getting even warmer than the city center. But anyway, a certain fabric, a certain distance between the buildings, a certain mass that especially during the day is able to reduce temperature. And what is happening is that a tree dries or dies, leading to major temperature. Same happens for grass, that when changes its fibers and becomes dry, actually accumulates heat rather than reflecting heat. So all these factors are quite important. Okay, so what? What can we do? So implications are quite high. So we use these models, and then we did some parametric correlation that help us to see how this is a timeline, how hydraulic flow are highly reducing with this temperature trend. Ecological river status is decaying, as well as there is a big decay of the number of pollen concentration. And there is a desynchronization between bees, butterflies, and other pollinators and the trees. So there are time of alteration of times that makes a desynchronization that is actually catastrophic for the natural ecosystem. But also, when temperature increase, also pollutants that are into air, despite there is an electrification of the car vehicles, are catalyzed. So for each degree of major temperature, the effect of particles of different size increase a lot, So respiratory diseases have increased tremendously in the latest year. You can see these the peaks, and these are data that we have got from local health authorities. But also the projection according to our models see that there is further bumps. And obviously, because of climate change, there is more radiation from the sun, and this impacts skin cancer. There is a huge number of cases in all Europe and also in this district. So even a few degrees means a lot, and obviously there are consequences for the buildings as most of the energy costs are shifting from winter to summer. So these are quite a big number to take into consideration. So up to now we have lived upon the paradigm of sustainable design, which says of do not do any action that compromise the environment, that compromise health. It's a law, sustainability is a law of conservation of the status quo we have already now. The question is this okay, considering that there is the degeneration we have been speaking about to be sustainable? Sustainability means actually to conserve current situation, or we need to do something to regenerate the context. And this is the quality of the planetary health or local health, we can say. So as quality of ecology and health decay, probably we cannot afford any longer to be just sustainable and have minimum impact or no impact. We have to have a positive impact into the context. And here come the definition of regenerative design, which is about have a plus into several categories. And I will tell you a bit more about that. So probably we can use many of the available systems. And what we've been using the most in Copenhagen has been the planet boundaries. It is actually a cake where is a slide referred to one of the elements of health for the environment. Some refer to water, some to air, some to ground, some to species. And in a very short time, most of these boundaries, which is the limit above which there is no possibility of reverse condition, have been exceeded in a very short time. So the question is, what can we do as architects or planners for this? So when it comes to the first category of the planet boundary, which is about climate change, obviously we can think of space that use the new temperature of the city as an opportunity. That will be the focus, one of the focuses of the lecture. When it comes to biodiversity, probably we can consider for each project how biodiversity can be enhanced. We know that European community is now forcing most projects since 2030 to have a biodiversity consideration. We can, for ocean acidification, we can clearly reduce the CO2 emission of our buildings. This is quite straightforward. When it comes to fresh water, of course, we have to think that the waters that enter into the city has to go out with the same quality. And I will probably leave you the lecture so you can go through some of this. But when it comes to perhaps if we can focus, let me get back of one. When it comes to atmospheric aerosol, so the different kind of particles, we can probably try to understand what amount of vegetation we have to place into our context in order to absorb it. So most of these findings are into this book, which explain a series of projects that are regenerative, and there is also some advice on simulation methods. You can download this book for free at the website of the Royal Danish Academy, and is 400 pages with the intervention of main offices like Big, Henning Larsen, and others. So we said that we have to shift from a sustainable approach, which is about mitigating, to an active approach, which is about adapting. And here is the first project I'm going to show. This is actually one of the largest development in the world now happening, where and it's in Riyadh. The idea is to create a new city, extension of Riyadh, that as compared to the other big project, the Neon, that probably everyone knows, try to root much more into design of ecological lines that are into the context. So it all starts around dry river. These are called wadis into the Arabic context. And the whole idea is to start before building the context of all this building in this 20 kilometer square, is to create before the biodiversity system and then begin to construct the different neighbors. This is quite controversial. As you can see, this is a skyscraper to give you the height. This is half kilometer by half kilometer by half kilometer. So it's going to be the largest building in the world, which is interesting because it casts a big shadow, which in a way keeps activating the context and creating always one area which is protected. But what are the challenges? So around here there is a certain these are lived elements that have each of them a certain, through these holes, a certain ecology within it, a certain protection, and this is supposed to be an area where also all the stream coming from the different river banks and these corridors turns around and creates some turbulence. So this has to be supported with some simulation, and obviously you can understand how long it takes to do a thermodynamic simulation as such for 20 square kilometer with the tools that you use in your course, like the debug tools and so on. And this is actually a radiation map where we can see how it's possible to create pockets of different colors. For now, let's simplify the language. Intentionally, around the wadis, there is an idea of create a zone of different temperature. So there is a certain flows and inner movement within the site. And there are other parts that are shaded. So the idea is not to create a reduction of radiation all over the site, but to create actually areas that where a heat flow will be generated in such way. Here it's a fluidodynamic simulation of how the winds work. Needless to say, there has been 10, 12 iterations with different form of the building, different massing, in order to understand how it's possible to activate, this is high velocity, how it's possible to have this movement of air, which is vital for an area in Riyadh that can get to 60 degrees at peaks in summer, because this may increase comfort, especially in certain time of the year. So, whereas this part seems to work, now we are working on all of these blocks, because despite the northerner wind, it at night comes in this direction, there is still here not enough turbulence or movement. So there is actually a work on cut and carving some of these shapes that are then given to the various archistar for development. But it's a several iteration where the climate has to be made for a large site. And it comes then to a huge problem for summer. This is actually the condition just with some optimization. And now we are working very much to bring the heat stress to reduce condition. This is the peak of condition for 2050 at 3 o'clock. But the idea is to play with reflective material, with misting system, with a series of technology to see what works and what doesn't work. It's a bit complicated because natural ventilation, for instance, doesn't work above 36 degrees. Above 36 degrees is like if you point to yourself an air dryer. So ventilation is not always a good feature. When air is higher than the temperature of the body, it's a problem. Misting systems are also problematic at certain conditions. As well as vegetation cannot sustain this type of temperature. So actually it's a very iterative process where you need a mix of several technologies in order to achieve a better situation, where probably even trees will need to be shaded themselves in order to survive within the context, and then the trees generates the comfort for people to stay. So we study actually the comfort of different species, try to understand on what temperature and radiation can stay. And this leads to several iterations for several months, where we have to design conditions primarily and surprisingly not for men to stay, but for other species first. So it's a completely shift of paradigm where the first target, at least nominally, or at least in our work, is the one to create an environment for multiple type of species. Project is ongoing, so let's see where it gets. This is for the city of Gothenburg. I will sit a little just because to use the mouse more often, otherwise we stay until 10 o'clock. Gothenburg is trying to expand, and there is a high pressure to sacrifice some of the forests, especially in the suburbs. These two have new layer of building, and also there are several built into the 60s that are considered obsolete by the municipality, and higher density investment are thought through. So the question we had is, what can we keep, what we can get rid? So each type of tree, or at least the three primary family, were modeled, as well as the different building fabric, shapes, and so on. This is a temperature at 2050 of the site, where we can see how certain areas get to 40 degrees up north, as well as certain buildings, at least during the day, go to very high temperature inside. Imagine a Swede living at 38 degrees, but when already 26 degrees is quite a problem for someone coming from Scandinavia. So a big shift from 2018, when we recorded the data and calibrated the model, to actually what is going to be in 2050. But we can see, interestingly, that certain areas, and this is almost like an X-ray, are keeping the same temperature. And also certain buildings, those in blue, if we look now or into the future, are at the same temperature. So this leads to the definition of thermal resilient. Thermal resilient, according to climate change, it's a building or a space that, despite there is an increase of temperature, keeps the same temperature of today. And it shows that is possible. We can see all these blue pockets of topography. So certain species, despite the climate changing, are still able to survive well within the context. Not all species. Some of the other species were not able to offer this performance. We can see these that change color. And we could see certain effect on lowering the temperature within today and possibly into the future. You can consult this data later. But what was striking to us, and we were not so intuitive back into the days, but now we understood the lesson, it's that this is 24 hours of the day, and this is the energy gain during the day and release during night. Buildings that are highly passive with thick insulation, during the day collect very little energy, but during the night release very little energy. So temperature remains stable. You can also think that these are curve of temperature to be simpler. Building that is hyper isolated, like the new offices they've built, same temperature day and night, with no mechanical system. Just like, it's so thick that there is no exchange with the outside. But the buildings that are built into the 60s gain some energy during the day. You can see the blue going up. But during the night, lose a lot of energy because actually they have very minimal insulation or no insulation. So for a residential building, for instance, you get much more comfort in summer if you live in one of the buildings in the 60s, but into this one. Imagine these are temperature, because there is a linearity between energy flow and temperature. Temperature are much lower in building into the 60s. And during the day, for instance, is not so much occupied. And anyway, there is no big difference between a passive insulated building and one that is built into the 60s. But what it strikes is that if the building is close to one of these areas where there is a sort of stable low temperature, during night the forest goes to much lower temperature. So if the building has little insulation, it's able to reduce even more its temperature. So this opened several other researchers, but it was the first time that we can measure this data on building with sensor. And it led us to think that we should not use European norms for insulation. If our building is into a forest, both in summer and in winter, we'll have a better context where it's much more convenient to have an exchange with the context. Okay, some other example. Perhaps I'll skip this project because it's a collaboration with Kengokuma office. So for some years I was at the EPFL as a researcher. We begin to have communication with different architects to do a sort of post-occupancy evaluation of performance. So these are the heat exchanges that are happening between the buildings and the context. So these are energy flow. And this was in construction back into the days, or in refinements, we can call. And this was the Art and Science Museum at the EPFL. And we did a thermal model of the full context, seeing what meshes or area were going to have very high temperature surfaces. It's easy for a surface to get to 80 degrees in summer condition, for instance. We can see an interesting fact. This is the old campus of EPFL, where surface temperature are much lower. Why? Because actually has very poor insulation, and the cooling load, the cooling of the outside or the inside also cool down the building surface. So there are interesting interaction between the interior and the exterior that can be evaluated. But getting into track, so the overall scope was how can we grant into the extension of the campus a certain acclimatization with a good outdoor comfort and a building that would provide a certain type of performance. So we first understood that after the simulation, and this was quite decisive, that the outer landscape needed to be designed with much more permeability, filtration, and with certain temperature. Also, the building doesn't have a mechanical system, and as you can see, the skin is purely breathing. It almost looks like a honeycomb. That, according to the simulation for different seasons, allows to capitalize on the condition on the outside. But also it was necessary to protect it with a very major cantilever. So it was an interesting dialogue also with the office of Kengokuma on how performance can match the language of the office. And primarily, 2 or 3 big openings for airflow were needed in order to cool down the this part of the landscape. And we can see how all these parts were almost cut in order to promote this ventilation and have some inlet of air within the campus in order to cool down that red surface we have seen earlier on. This is the development where key passages are emphasized in order to have ventilation. And now if you visit there, you can see a prominent amount of vegetation. Okay. But at a certain point, we had a doubt. What if we are not working to control temperature, but we play with temperature? So during expedition in Atacama Desert and working on the city of Famagosta, we track and put sensor in several buildings as well as on the outside, getting an understanding of the thermal behavior across the year. Of course, summer for them, it's a little bit chiller. And at the same time, we were having contacts with Dr. Kramer that back into the days didn't have this intuition. This is a paper he published this year, where actually for human, it's probably more convenient to live in buildings that are less acclimatized, that have different temperature, where there is certain cold area, certain warm area. So it is proved by several of his studies, but this is now understood, that adaptation with shivering for cold, or sweating, or other mechanism of the body to adapt in places where we spend most of our hours, are very precursor of health. And people that works and live in steady thermal environment with air conditioning in both seasons are more prone to incur into chronic disease, as well as to develop primary diabetes, but several other type of diseases. So it was found out that it's better to make the body work. So we begin to think in some master planning for the city of Famagosta for certain key areas. What if we accept that there is areas that are overheated and some that are chiller, and we begin to think of activity that moves from a landscape of thermal environments, as well as if we do not want to create the cool or the warm city, we want to choose the right type of species, both for fauna and for vegetation, that can adapt to the different phases. So this was then supported, especially for one building, with some simulation, in order to, capitalize and even make this differentiation higher, so that depending on the time of the day, you can move through the building, or species and animal can really enjoy this type of changing element. This concept was brought into a consultancy for, again, our friend Mario, where somehow there is a landscape of different temperature at different heights, but primarily these boxes are not acclimatized. So this is an office building. Depending on the time of the day, you can get into boxes with different temperature for, these are open space for work or for socialize, but you can navigate and experience different temperatures. Some are overheated, some are cooled down. Also, it's interesting anyway to bring down the level of temperature, for instance, and I'm just talking about the summer scenario, having a forest according to the prevailing wind, and having one of the few suspended buildings in Milan where air compress, accelerate, and then it's possible to create a microclimate. Furthermore, in summer, do you remember the sun angles we discussed at the beginning of the presentation? In summer, in winter, these blocks that are black are activated, so they can go to 60 degrees of temperature. They only get heat during winter, and then they create a certain microclimate around them. So it's possible to have this climatic solution that determine, or at least increase, the usability of the outdoor and the quality of the thermal experience within the interior. So some years ago, we won this competition with Cino Zucchi for the Lavazza headquarters. And we try to bring this concept of thermal variation also into every, let's say, window of a building. So each of these is spandrel with different colors, each of which receive and absorb a certain radiation. Panels of different insulation. So if you touch them from the inside, you will have a different temperature. And then there are trombi wall and double skin facade within it. It's part of an overall concept of regenerative design, where there is also matters of water and creating an ecosystem with different temperature for the site. and there is a composite of solar envelope so as not to to preserve the right to light of the context. But perhaps I will talk about this aspect into another project. In general, we can also see how back into the days was not so developed this discourse about fluvial and pluvial water management into the city. But the overall idea for the context is to create a different temperature as well as other possibility and ways to accumulate water or absorb water, keeping water into the site. Keeping water into the site, especially in certain season, can really create a certain microclimate. But working on the simulation, and this is the mechanical engineer dreams, where energy is flat, each facade has a certain radiation, and the project started like that, with a dialogue with the mechanical engineer, where they'll say, okay, here we use this facade when it's red, when it's yellow we use another facade. But they didn't know I was going to create the chaos. Because actually, the idea we developed with Shinozuki was, what if we alterate within the same facade the amount of energy that enters and exits? So what if the flow are modified so much that depending on where you are into the office, then you have a different experience, which is about thermal, but it's about daylighting as well. So these are some of the final effects. Unfortunately, I don't have any data because they didn't let any post-occupancy evaluation, but I still have some hope. But the idea is that then people would relate to the facade and to the different condition, also create a landscape within the interior which is not rigorous, but there is a certain fluctuation of people within the context. Same for this facade in Milan, where the composite is done but with shading elements that randomly or semi-randomly do not have the pure function of shave certain incoming energy, but the idea is to partly reflect, partly absorb, partly minimize. As an example, I took this picture for a place that in this moment is not even exposed to light. So it's completely casted shadow, but due to the reflection of these panels, light is casted in, and you can see how certain light can be even casted into this direction. So when light comes into a space, it creates different condition of daylighting, but also of temperature, because light comes with a certain amount of short wave, which comes with heat. So, and we did some recording on this black pane, recording very different temperature, even when it is in shaded. Imagine when it's then not into that state. And this is the northern facade, where there is a color code for the insulation. So each of these has a different thickness of insulation. And your question is, okay, but there is a regulation, right? You have to respect. So the trick is to provide then only the average insulation. You have to reach the average insulation by law. And, but this is the way around. And so depending on where you are into your unit, you can have then, again, this differentiated type of behavior. And same for the outside. Clearly, some panels on the outdoor gets warmer into winter or in summer overheats, but it creates a landscape that we believe it represents the diversity of temperature that there are in to nature. Similar concept applied to other consultancies. This is for the Census Bureau in Maryland, where actually there is a randomized pattern of shading system that for offices and a density that varies, so that it's possible to create different incoming energy, and this frame changes from office to office, as well as this is an hotel in Hyderabad, a consultancy for SOM, where we actually even engineerize the facade to answer to the position of thermal receptor within the body. So we know that cold or warm are perceived. We have more warm receptor into the chest because we have to protect certain organs. We have cold and warm receptor into the ankles, into the wrist, as well as the head as a certain amount. So the idea is to create a facade that keeps changing so that you have this different type of articulation of sensation depending on where are to the space, and this was then linked to an algorithm to generate. Also, it's not all about the body strip, but it's about the perforation level that changes from side to side, and then the temperature that can be gained by different temperature. So more recently, I'm collaborating with Italian train station company, and specifically, this is perhaps we have 7 or 8 stations. The objective is to have full comfort in 2050 without the use of mechanical system. So there is a new rule that says that somehow, despite the boundary of climate change, this have to happen and work without mechanical ventilation. So we tried to analyze temperature and all patterns for 2050, and we tried to model the building so as to reach as less possible temperature and have a good comfort within it, but it was impossible. So we needed to increase definitely factors once we have shaved already solar radiation and the envelope was optimized. The overall concept was, let's try to make a building that works like a Formula 1 car in a way, and that is able to take air from its longitudinal axis, but also from the side. And we begin to relate the station position to how airplane works when they arrive in Fiumicino in Rome. We notice that depending on the wind, actually the tower of control tells the pilot whether to land in this direction, or this direction. So wind becomes quite an interesting factor, of course, like many areas in proximity of the sea. And so we did actually sort of different tests with computational fluid dynamics simulation, also with some wind tunnel, but I didn't put it here because we're having some problem. But in general, air enters and gets out in this direction, or does the opposite. We can see the air inlet, how it works. So it has 2 air inlet, but depending on the time of the day, works on different directionality. And then at summer night, when wind is transversal to the body, it enters from the side. And there is no automation, so the building is always open, and there is enough pressure to keep the 2 directions working without any type of automation. We also tried to optimize this system with certain strips and warming up this part, because we know that when certain bodies warm up, attracts air. And this is the last scenario we are trying to study when air is fully stuck and there is no movement. But in general, if we look at the inside, what you want to have for a good building, it's areas where comfort may change. It doesn't matter if certain areas are at very high temperature, but it's very important that there are areas that are chiller, areas that are slightly warmer, so there is a differentiation. When there is this differentiation, there is also autonomous flow within the interior, and also people can have this nice feeling to feel in a space that is vibrant, thermally vibrant, where there is variation of condition. More recently, we are working on a student house in Milan, a big issue in... I saw beautiful student house in Cracow, by the way, of new construction. I was very impressed. In Italy, this is not possible at the moment, but now there has been a lot of protest from students to have a place to stay, especially in city like Milan, where rents are very high. And just to open up a thinking on key performance indicators on how to develop the massing on top of what is architectural intuition, regulation, and what a building form can offer to the context. And so we developed 10 scripts in Grasshopper with 10 key performance indicators. Some are more classical, related to how changing the massing you can harvest energy or reject energy. But we wanted to bring into the building and for the user and for the city elements like how it's possible to, what are the best surfaces into a building to have green walls? What are the best surfaces? Actually, this is about butterfly and bees optimal location. Where vegetation should thrive, so each color corresponds to parts of the building. And this comes almost forced from the simulation for human comfort or other factors that contribute to the massing, such as contactedness to nature. So the view factor of nature, which is purely a geometrical calculation. Sky view factor, how much of the sky can be seen from the site and from the buildings, or right to light. So develop something that allows the context to receive a certain light. So each of these factors comes from several massing. Perhaps there are 10 massing that are confronted. And for instance, here we can see for the vegetation stress, we know that vegetation needs to have a certain amount for photosynthetic activation. But when radiation and temperature are too high, then there is a certain issue due to the fact that species cannot survive climate change, as said before. So we can see all in brown parts where if vegetation is placed, it will die for sure. There is no future for vegetation unless further shading systems are into place. So these are very simple ways, and again, it's a comparison with different proposals until a certain balance between architectural intention and composition of performance is reached. Just to show a little bit the process of an ongoing work. But it's very important also to do on-site measurements. These are some work with students in Copenhagen in the Faroe Island, especially because in that time we were asked for consult on the new, let's say, educational building in the Faroe Island, where part of our effort was on the optimization of energy performance and daylighting. So work with the shape, with different iteration from the design team. But primarily, what we wanted to bring as a performance for the future in an environment which is extremely cold is protection from wind. And what is happening with climate change is that grounds and water or streams have very different, or will have very different temperature according to the regional model than today. So a critical issue or solution is how can we create areas that are always protected from. So this is almost overlapping with the wind rules for 2050. And if you listen to Bjarke Engel's narrative, of course, he focuses on many other factors and on his original ideas. But whenever and wherever the wind comes from, there is always areas that are protected. So this links a little bit to the concept of regenerative design, which is about increasing the quality of condition also for the surrounding context, increase livability. So this net plus, but it's possible to grant for each of the projects. But other ideas were scale up. For instance, these were the studies into the Amazon and into other contexts about nets, embed nets, using us as bodies and with a set of sensors to understand what is the correct layering in order to achieve a certain comfort within unit while protecting from vectors. And this has led to several studies from the head of the school in Copenhagen, Jacob Knudsen, of integration of all these findings into a series of envelopes for new houses that have been optimized through, we study the optimal configuration, I think for 3-4 years from Tanzania to Thailand to understand what for tropical areas can be a good solution. We can see, for instance, some concept like suspended cooling of the basement and the foundation, as well as having thermal mass, open kitchen, certain values. As you know, in Tanzania, they cook and have all these particulates within the interior that are not open to ventilation. So there are several other factors, but focusing on the scaling up of technology, we can see how that has led also to certain houses called star homes, which are nicely protected, but where the envelope is no glass, is no plastic, is just a net to control ventilation and to protect from malaria. So these are the nets that contribute to these new types of frugal homes for the context of Tanzania. Experiments were many in Copenhagen, for instance, tracking and develop system for public space that use the drying effect of fishes in order to create a better microclimatic environment into Norway, for instance, or system that use the permafrost melting biocomponent in order, this was a collaboration with the NASA, in order to create, let's say, protein production as well as clean air within houses in a context of lack of food harvesting. And perhaps I'll show some of the works done with the students in the Master of Architecture and Stream Environment in Copenhagen. Okay, I hope there was sound, but eventually not much. So I will not sing, but it's a pity because there is a voice explaining it. So we'll tell a little bit more myself. So the idea is to create small prototypes, one-to-one, that are plugged into place in order to take a problem and transform the problem into a solution. So Magnus, the student, developed a system, most of several panels. The production happens in a couple of months after a research phase in Copenhagen in September. And he found an abundance of clay within the context in the urban fabric, but also an excess of CO2. Imagine that the level of CO2 into the city can get to 1,500 ppm. Above 800, you already begin to experience headache. Just to give you an idea. In this room, the more we are staying, the more CO2 it's increasing. But in city is a dramatic problem, and it's important to understand how to use CO2 as an opportunity to, for instance, enhance growth of vegetable. So all the study is conducted, and perhaps I'll speed up a little bit the process, on how exposed or non-exposed to CO2 panels can lead to the growth of tomato within it, capitalizing on the water coming released from mechanical system like this. So all the externalities that are negatively impacting city are then used as a resource for this type of developments. And this is also like a mapper of different CO2 opportunity within the city, where then different growth are happening. And then the experiment, I would say, becomes quite architectural and scientific at the same time. Let's see if I can scroll to the next. Okay. Also for this one, it's a pity. This is in Chile, where Harry developed a system that it's about water, lack of water. It's about lack of electricity for many of the favelas in Chile. It's about creating informal elements that can be plugged into the houses and be understood by local people. So sound is not working, but I will get perhaps to, it was also interesting, the whole system and the mechanics, but without words is a little bit complicated. So this system, which really works in a banal way, was then finally even copyrighted because it allows even to have enough electricity for a TV and to provide light the full night, while also providing at any time clean water. So depending on the size, but the nice thing is that it can be really implanted into many different roofs and answering to current issues. Okay. I think perhaps I don't have it here, another presentation. But it would be nice if we can have a small debate, or if we have any set of consideration or question with you to have a small debate. This to be in contact on Instagram for climatic works. But perhaps I will ask you, what is your approach to climate change into your project? Are you considering it? Did you imagine so much implication of even a few degrees of change? Blank. Okay. No, I understand. It's actually my experience wherever I go, so do not worry. In a way, it's about making design much more interdisciplinary. We all come from a certain way of thinking architecture and urban planning. And the solo approach has led to several unsuccessful cities, right? Because when it comes then to being in contact with the ecological system, when it comes to our health within context, when it comes to have decarbonization, then there is a big importance on how we develop the massing of our building, on how we treat and develop surfaces. And it takes probably a big shift into the project, but it's not so, let's say, far away. And I noticed that even just if you just consult my book, where, you know, when we talk about ecology, there is not so much to know about it. It's about understanding beyond our comfort zone and understanding the comfort of different species, and how it's possible to create almost a small ecosystem engineering that comes from your dialogues with experts within the field. But it's very important that the building also contributes to create the condition for ecologies. For instance, it's possible to create certain rugosity within the articulation of building, certain pockets, certain open areas, certain geometrical correlation that really allows for biodiversity to exist. When it comes to, this is the first aspect, ecology, I would say. The second, it's about creating a microclimate, outdoor and indoor, with no use of energy. And again, for the outdoor, the natural layer, the ecological layer is a big contributor, but we have to create conditions for the ecological layer to produce this performance. And a very simple advice is just to study the winter and the summer scenario, the two extremes, starting like we were doing with the Tennessee studio, with understanding the shadow profile and just having temperature on your side. Without going into very complicated simulation, if you're able to control these two parameters, you already have a lot of information, and you should iterate and change your massing or your design for that, and so on when it comes to the interior of the building. Health is a big factor because cities are actually creating conditions that in most of the cases are detrimental to health. And there is only an intuitive interest into biophilic design. But science shows that contactedness with nature clearly improve our health. And into the planning of the city is very important to create the mix of mobility means, proportion within the spaces, and ecology that allows to have this good health. And what is transparent, like air quality, then becomes something that is manageable in different ways. The final aspect is perhaps the carbon picture that I haven't presented here, but perhaps I will spend some more words as there is more time. Are you able to say how much CO2 tons are you emitting per year as a citizen, as a person? How many tons of CO2 are you using? So, as an average, an American citizen spend about 20 tons of CO2 per year. An European around 10. In certain countries where there is certain condition, 7. But, no, perhaps I didn't want to show you already. Okay. So if you build 1 square meter of a building, what is how many tons of CO2 or kilogram of CO2 it costs to build 1 square meter of a new building? No idea, right? Okay, then I have to show. So depending on where, but in United States it costs around 500 kilogram of CO2. These are the emitted CO2. This depends on the country. I think Italy and Spain are around 250. Poland, it's more likely like Germany. And retrofit also costs this amount. If you have a retrofit for 100 square meter, it's 28 tons of CO2. So one American citizen, more or less, in 1 year, emit as much CO2 as to do a full retrofit of a building of 100 square meter, more or less. So this is very interesting when we talk about carbon emission, because personal emission are, for instance, much higher than the one for construction. There is also another false myth. I will get to that later. Yeah, Italy is 370. Yeah. Okay. Depending on the type of material that we choose, we can reduce very much the amount of CO2 for construction. Now I have a question. Imagine a city with a different zoning: residential area, commercial area, industrial zone, transportation networks. So this has been a long work, but we understood, or kind of have average value of how much are the emission for construction in different areas. Industrial zone, for instance, cost much more. Also, transportation networks are very high in terms of CO2. Even, there is a carbon associated with the maintenance of water bodies. Parking lots also have some construction, let's say, in terms of CO2 cost. And green space have even some emission of CO2, despite they are absorbing. And this is due to the fact that there is maintenance. When you cut them, when you trim, when you put irrigation system, So there is a cost also for that. However, there is not only the cost related to the construction, but there is the one related to operation. In general, every year, per every square meter, there is an emission in kilogram of about 200 for residential area. If we go to industrial zone, clearly this is almost three times more. So there is these are very important units when you begin to plan a city and when you want to mix the different areas in order to achieve a certain carbon balance. But to get to then a good value, what we need to have, and these are average for other areas. Let's see if I have the slide. Okay. So if we use certain building asset, it's possible to have certain, even construction for industrial sites, that during construction are carbon negative. So they attract and absorb and stock more carbon than the one for the making. All this number can be and should be combined in order to get to this minus. It's quite utopistic in these days. And let's see if I have the, okay. Okay, now I have a small question. Let's see if I found it. Just for the newcomer, the lecture is finished, but these are further discussion. No, just to this is an extra discussion, but we spoke before. It's just to, no, you can stay. Obviously. What is the carbon absorption of one tree? I'll hide, otherwise you read. You remember that you have an emission of 10 tons of CO2 per year. And you remember that to build 1 square meter, it takes about 200, it emits 200 kilograms of CO2. What is the absorption of one tree of this outside? You emit 10 tons per year through your life. What do you think a tree can do? How much CO2 can be absorbing? Okay, half ton are about half ton is 500, considering that a big tree absorb 22 kilogram only. So to reach half ton, we need 25 big trees. So to offset one of your here, as European average, of 10 tons, you need basically 25 to plant 50 trees. Yes. So imagine how we are, somehow we have this narrative of the importance of planting trees because they offset so quickly. And it's true. I mean, during their life, they do a big good. There are several other benefits, of course, in terms of microclimate, purification of air flows, creation of a biodiverse environment, and so on. But if we begin to compare how much we spend, the cost of the CO2 for construction and the trees, I was very shocked when I began to study 2-3 years ago all this data into detail and talk to people that do all these studies. But when we have to then plan the city of tomorrow, the key saving are not so much through trees, through a lot of vegetation, and it's not so much about the building, it's about the people. So people lifestyle, like you're doing the 15-kilometer city, or like, compact movement, most of the personal CO2 emission are due to transportation, our diet, and to, for instance, the efficiency of our houses, which is anyway related. But it's very interesting that there's a lot of creating a space which is able to induce to a certain lifestyle or to a certain possibility. So perhaps I try to improvise this further discussion to fill the time because I finished too early the other presentation. But something to think, because when I begin to see all this project with a lot of vegetation, there are several benefits, but it's very important that we use these tables that are very simple to put some number about CO2 when we think about carbon. So yeah, that's why I think it's, I believe it's important to incorporate some metrics in our works, in our project. Clients are asking more and more evidence-based type of projects, right? It comes very easy for interior design because, of course, it's a simple multiplication of materials, CO2 impact by volumes, but the city, of course, is much more dynamic, yet something not so difficult to measure today. Okay, I think, yeah, that was it, perhaps. Okay. Any question, perhaps? Yeah.